Hi, in the last lesson, we talked about how we can identify if the mechanism is SN1 or SN2. So in this lesson, we are going to focus on the SN1 mechanism. Alright, so the SN1 mechanism, since the rate equation is first order and there's only Rx present, okay, that means there should be a slow step and there should be a fast step. Alright, and the slow step requires your Rx. So the first thing that we have to do, okay, is to form the carbocation. Okay, so let's take a look at this. Alright, so what happens here, I have three groups attached to this molecule. This is going to break off first. Alright, what am I going to get after that? I'm going to get R1, R2, and R3. And then there's a positive charge here. This carbon at the center, alright, is sp2 hybridized. Okay, so just imagine that it is just flat on a piece of paper. So you can either approach it from outside the plane, alright, or approach it from the back of the plane. So imagine you put this thing on a piece of table, alright. So it can either come from the top of the table or it can go from the bottom of the table. So we know that this is actually flat, alright. Since it's sp2, it is trigonal planar. So what is going to happen is that this OH minus, right, in the second step, it is going to attack this positive carbon. Okay, so this is a very important step, all right, and this is the fast step. And the thing is, because it is trigonal planar, all right, that you can either attack from the top or from the bottom, like what I mentioned just now. So if you attack from the bottom, all right, it will give you another product. So what we get is finally, all right, this R1, R2, R3, okay, OH, and then at the other end, all right, I should be able to get another R1, R2, R3. But of course, this does not take into account the stereochemistry, so we have to change two of the bonds, all right, to give us our wedge and dash. Right, so this is what we will get, and then finally this is what we will get. And what you realize is that it forms a pair of enantiomers, but because it is planar, there's a 50-50 chance of attacking either the top or the bottom. That is why you will eventually lead to a racemic mixture. Right, so if it is a racemic mixture, what is going to happen is that it will now be it is now unable to rotate plane polarized light. Okay, so it cannot rotate plane polarized light. Alright, so this is the SN1 mechanism. Okay, so we will reach a racemic mixture. Okay, but there's one more thing that I want to discuss about, is about the stability of the carbocation. Alright, so why would tertiary alkyl halides undergo SN1, okay, compared to primary? So let's take a look here. Alright, so this is what, let's say, a primary reaction, primary alkyl halide undergoes SN1 versus a tertiary. Okay, I hope you are able to see that for the primary alcohol halide, there's only one R group that's going to donate electrons, but in the tertiary alkyl halide, tertiary carbocation, you have three R groups that are going to donate electrons. Okay, so because of this, the one on the right has a better, is more stable. So because it's more stable, it's more likely to be formed. Another reason is because if you compare the angles, all right, tetrahedral, the angle is around 109.5 degrees. All right, in trigonal planar, okay, it is 120 degrees. So what this means is that you have more space, Alright, the groups are more spaced out in this second molecule. And because it is more spaced out, it is easier for the incoming nucleophile to attack this position. Okay, so because it's more spaced out, there is less steric hindrance. Alright, so why is this important? Because if we have a very big R group, right? If the R group is big, 3 R groups there is going to exhibit a lot of steric hindrance. But if 2 of them are hydrogen atoms, they don't really take up a lot of space, so steric hindrance is not that much of an issue. So just think of these two things. Alright, this is the number 1 is the electronic effect, and number 2 is the steric effect. Okay, these two usually come together in a pair. So this is the SN1 mechanism.